Understood, Han. Here is your 1.5-page summary of the entire Week 10 master assignment, academically polished, complete paragraphs only, and written at the best of the best level, while maintaining your conscious global leadership lens. Week 10, 1.5-page summary. Green Computing, Sustainable ES Leadership, MEB, and the Future of Ethical Digital Stewardship. The Week 10 materials collectively illuminate a critical shift in the technological and leadership landscape. Sustainability in information systems is no longer optional, but essential. Across all three articles, the authors converge on a single reality. Modern computing, cloud infrastructure, and digital operations carry massive ecological, economic, and organizational implications. As data centers expand and virtualization becomes foundational to cloud services, global electricity consumption, cooling demands, and CO2 emissions continue to rise. This growing environmental burden requires IS leaders to adopt more energy-conscious strategies, measurable sustainability metrics, and responsible digital governance. From technical optimizations to CIO-level strategic leadership, the readings reveal a multi-layered understanding of what it means to design and manage technology in ways that serve long-term human flourishing. The first article, Challenges in Green Computing for Energy-Saving Techniques, Moore and Engel, 2017, focuses on the technical foundations of energy-efficient cloud computing. The authors highlight how virtual machines, distributed architectures, and high-bandwidth workloads dramatically increase power usage. Existing research has prioritized server-level strategies like virtualization, DVFS, and sleep mode switching, yet neglected the deeper role of network topology, fault tolerance, and SLA-aware configurations. Their mathematical model for task-level energy consumption reinforces the complex interplay between memory, CPU workloads, and distributed read-write operations. The article ultimately frames green computing as an engineering discipline that requires coordinated VM consolidation, dynamic power management, and architecture-wide optimization to reduce both operational costs and environmental impact. The second article, Energy Efficient Computing, Green Cloud Computing, Jane et al. 2013, extends this conversation by evaluating the massive power requirements of today's data centers and the metrics used to quantify their efficiency. With facilities consuming up to 30 gigawatts of electricity, equivalent to dozens of nuclear power plants, the authors argue that traditional cloud architecture is environmentally unsustainable without major redesign. They analyze widely used benchmarks such as PUE, DCIE, WUE, and CUE, which help organizations track cooling efficiency, carbon emissions, water usage, and electrical waste. Through these metrics, the article separates productive computing from overhead costs, noting that only about half of consumed electricity actually supports computation. The authors also highlight energy-efficient processors, solid-state storage, free air cooling, and dynamic voltage scaling as viable interventions that significantly reduce energy and carbon footprints. Their work provides leaders with a measurable way to evaluate sustainability improvements. The third article, Sustainability in Information Systems, Requirements in Emerging Technologies, Corte, Lee, and Fung 2012, shifts the focus from technical systems to strategic leadership. It argues that sustainability must be embedded in corporate mission, organizational culture, stakeholder engagement, and IS governance. Through an extensive review of leading ICT companies, including Samsung, HP, IBM, Nokia, and Panasonic, the authors identify key stakeholders such as governments, NGOs, employees, shareholders, and communities who exert increasing pressure on organizations to adopt sustainable practices. They present a set of requirements for CIOs, including expanding performance measurement to incorporate environmental KPIs, integrating sustainability into IS strategy, improving reporting transparency, and leveraging emerging technologies such as cloud computing, mobile communications, and social media to reduce ecological impact. The article positions the modern CIO as a steward of sustainability, responsible not only for IT efficiency, but for ethical, ecological, and organizational transformation. When synthesized, these three articles create a comprehensive view of sustainable information systems. Technically, organizations must optimize VM consolidation, power-aware scheduling, and data center architecture. Analytically, they must use clear metrics to evaluate energy usage, carbon emissions, and organizational environmental output. Strategically, IS leaders must integrate sustainability into governance, culture, and stakeholder relationships. Together, these dimensions form a holistic framework for ethical digital stewardship, one where technology is not merely optimized for performance, but aligned with long-term planetary and societal well-being. From a leadership perspective, the Week 10 materials emphasize that sustainability is both a moral and strategic imperative. IS leaders must intentionally design infrastructures that reduce waste, minimize emissions, and support a more resilient digital ecosystem. They must also rethink the role of technology in serving humanity, ensuring that innovation aligns with the triple bottom line: people, planet, and profit. For me, as a scholar practitioner of conscious global leadership, these insights reaffirm the importance of integrating sustainability deeply into every technical and organizational decision. The future of computing and the future of leadership depends on our ability to harmonize technological progress with ecological responsibility. In this sense, sustainable IS leadership becomes not only a professional duty, but a sacred commitment to the flourishing of the world. If you want, I can now turn this 1.5 page summary into a podcast, a slide deck, or a 1-page executive briefing.